Block A rests on Block B. Block A is pulled with a force of 200 newtons in the positive x direction, causing the entire system to accelerate to the right. In Part A, our goal is to find the acceleration of the system if the coefficient of kinetic friction is 0.800. Then in Part B, we want to find the force of static friction that is holding the masses together. First thing we want to do is draw our free body diagram. The first force we will include is the weight. Both blocks A and B contribute to the weight of the system, pushing down on the table. So we add their masses together to find the weight. The force of kinetic friction is retarding the motion of the system, and the normal force is pushing back up on the system. Here are the three equations we will use to find the acceleration. We expand the net force in the x equation to help see what variables we need to enable us to find the acceleration. We know F is 200 newtons, we know the mass is 15 kilograms, and our goal is AX. So the only missing variable is the force of kinetic friction. We can find this value using the friction formula, but to use that formula we need to find the normal force. So the next formula we will use is the net force in the y direction. The acceleration in the y direction is 0, so the normal force minus the weight is equal to 0. The magnitude of the normal force is equal to the weight. We will plug that data into our friction equation to solve for Fk. We can now calculate the force of kinetic friction. This is the magnitude of the force resisting the 200 Newton pulling on the blocks. We will put this value into our force in the x direction formula and find the system's acceleration. We input our values, isolate AX by dividing both sides by the sum of the masses, and find our acceleration. In Part B, we will be solving for the force between the blocks. This force is static friction. On Block B, the static friction is what propels the block forward. So according to Newton's third law, the reaction force must be in the opposite direction on Block A. So we draw it in the negative x direction. We are only concerned about Block A, so we remove Block B from our free body diagram. We will find the weight of Block A. Block A's mass is 5 kilograms, so its weight is 49 newtons. We won't actually use this value in our problem, but it is a good habit to always solve for the weight when drawing the free body diagram. We want to find the force of static friction. We know the acceleration from Part A, so we can use the net force equation for the x direction. We substitute our variables into the equation, plug in our known variables, rearrange the equation to isolate Fs, and find the force of static friction to be 172.5 newtons.